Hello everyone, this is my first experiment of Internet Routing Protocols Lab, and my name is Joel Philip. This first experiment is about EIGRP. So EIGRP basically stands for Enhanced Interior Gateway Routing Protocol, which can be explained as an advanced distance vector routing protocol, which is used for like computer network, which is used in a computer network for automating the decisions and configurations in a network. Now, the specialty of EIGRP is that uh, EIGRP EIGRP lets routers exchange more efficiently than with earlier protocols, because earlier protocols has certain limitations, because from when the packet is switched from one network to another, there are some limitations for the previous protocols. So the when I am talking about previous protocols, I'm saying IGRP, which stands for Interior Gateway Routing Protocol. So here we are going to consider a topology. Uh, so I already have some here, so I will reset the simulation. And basically, the specialty of IGRP was that why we use EIGRP is because it can interoperate between the metrics, because uh, yeah like unlike IGRP, EIGRP can be used for multiple networks. Like in this case, it can be used for internet protocol IP networks, and another specialty of using EIGRP is that using EIGRP, a router keeps a good copy of its neighbor's routing tables, which we are going to see in this topology. So yeah, it's working now. So we'll close this, and then this is the topology that we have made, and this is the topology we are going to consider now. So first, let's see whether the basic part of any topology is we have to test whether uh, the workstations or the components are working or not. So let's check whether the packet which I'm sending from one workstation is getting pinned or not. So I'll delete all, start a new one. Just a second. So this is the thing. So look at this, we can even see what's happening in real time. So as we can see, the ping is successful. Similarly, I can ping packet from this workstation to this workstation. So as we can see, the ping is successful. So now, as I said earlier, that using EIGRP, you can a router keeps a copy of its network's routing tables. So what does this mean? We are gonna see it right now. So suppose here we have one router. We are gonna take this router, and then we're gonna check the functionality. So as I said, we're gonna see whether it shows its adjacent neighbors. So since we are using EIGRP protocol, EIGRP neighbors. So yeah. So see, as you can see here, there are two main adjacent networks, that is router 1 and router 2, and it shows the details of its adjacent neighbors. So That is basically the specialty of EIGRP. It also records uh, the you know the details about its adjacent neighbors. Also, I mentioned earlier that it can be used in networks which uses IP protocols. So let's see how it works. So let's check for IP protocols. So yeah, see, as you can see here, uh, it clearly mentions about how EIGRP works, update, its outgoing update filter, incoming update filters, and all the details. So what else we can do? We can also ping from here. Uh, just a second. Now I showed you the pinging process graphically. Now let's see how the pinging process works when we are working in a command prompt. So let's open a workstation. So so here we go to the command prompt. Now let's try to ping an adjacent system. So ping 1, 2, 5, 6, 7, 8, 10. See, here what I did is I took this workstation and I tried to ping this network. So as like clearly we can see here, the number of packets sent are 4 and the number of packets received are 4. So and it shows 0% loss. So it shows that the entire topology is working correctly and we can ping it. So this shows that this given topology is successfully configured and it's pinging successfully. Thank you.